Hello, everyone, and welcome to Zemarc's Hydraulics 101 training program. I'm Bernard Hefner, one of the sales engineers at Zemarc, and the person that will be leading you through this training. In today's course, we'll be covering and discussing different types of sensors and all the ways that they can interact with your power unit and provide crucial information to keep you, the user, informed on the efficiency of said unit. Now, before we get started, we of course want to introduce ourselves and provide a visual on just how Zemarc operates and provides service in the fluid power industry. As you can see, Zemarc has four branch locations in the state of California, with two being official Parker stores, Oxnard and LA, and two being official hydraulic service centers, Fresno and LA. Between each branch, we offer and cover a wide variety of industries, from agricultural and industrial applications to more specialized ones like aerospace and automation. We do repairs, testing, custom parts unique to your application, and a multitude of other services to make sure you have your system running optimally. All things considered, we here at Zemarc can supply you with the hydraulic and pneumatic components you need and the technical expertise that is required to spec and operate them. So, now that we've fully introduced ourselves, let's get into today's Hydraulics 101 training on sensors. In today's world, where accurate and efficient measurement is essential, staying up to date with the latest sensor technology is crucial. Upgrading and updating sensors not only improves accuracy, but also increases productivity and reduces costs, making it a necessary step for businesses to remain competitive. We'll also explore the different types of sensors and their applications, giving you a comprehensive understanding of the importance of sensor technology in today's world. So in this training, start by discussing what accuracy means in sensors, the most common types of sensors available in fluid power, and their associated technologies. We'll also get into sensor applications and finish off with discussing design considerations for sensors. We hope that by the end of this training, you will have a better understanding of the benefits of upgrading and updating technology, as well as the different types of sensors and their applications. Thank you for joining us, and we hope you find this training informative and useful. If you have any questions, please feel free to enter them into the chat and we'll address them during our Q&A session at the end of the training. All right, so let's get started. Hydraulics 101 on sensors. In our last training session, we focused on predictive maintenance and the important role it plays in keeping your system running optimally. Sensors are equally crucial to the role of predictive maintenance through the use of live data review they provide. The use of sensors can provide more accurate timelines on the consistency routine maintenance of equipment, which will need to be done, which can prevent costly unplanned downtime. They can help maintain equipment longevity through accurate data on oil and pressure, which can help the user be proactive to something like contaminated fluid or pressure spikes and buildups. This is all done through condition monitoring with the sensors in your power unit. So, accuracy refers to the degree in which a measurement or reading corresponds to the true value of the quantity being measured. It is a measure of how close a measured value is to the actual value. When we measure something using an instrument, there can be a difference between the measurement displayed by the instrument and the actual value of the quantity being measured. This difference is known as the measurement error, and it can be caused by various factors such as instrument calibration, environmental conditions, and operator error. High accuracy is important in many applications where precise measurements are required. Repeatability is also an important factor in many applications, and this refers to the ability of an instrument to produce consistent measurements when the same quantity is measured multiple times. High repeatability is desirable because it increases the confidence in the measured values and reduces the need for repeated measurements. Linearity is another important factor, especially in control systems and automation applications. It refers to the degree to which the instrument's output responds linearly to changes in the input. A linear feedback system is easier to program and control, and it provides more precise and predictable results. In summary, Accuracy, repeatability, and linearity are all important factors in various applications where precise measurements and control are necessary. A high level of accuracy and repeatability leads to more reliable and consistent results, while linearity facilitates the programming and control of feedback systems. So, sensor types. Sensors will fall into one of three main categories: preventative maintenance sensors, diagnostic sensors, and control and feedback sensors. Each type of sensor is designed to detect a specific type of physical parameter and convert it into an electrical signal that can be processed by an electronic device, such as a PLC. So, common ways to conduct preventative maintenance include the regular checking of fluid level in the reservoir and the level of contamination in the fluid. And with stuff like the Tempesonics LLE and LLH sensors, linear feedback transducers, these are designed to give feedback on fluid level. Or you also have things like the Parker I count, which is a particle counter that gives you real-time feedback on contamination levels in the system. And then diagnostic sensors give continuous feedback while the system is working to help monitor system conditions and pinpoint potential problems such as contamination and leaks. So the STOF PPC gives feedback on contamination levels, fluid temperature, and pressure. Then we have things like the Barksdale differential pressure sensor, which is designed to measure the difference in pressure between 2 points. Or you have control and feedback sensors, which aid in controlling a system. These often include temperature, pressure, and position sensors, like the Tempesonics R Series 5, linear sensors, which measure the position of an object, such as a cylinder. And last, Barksdale pressure sensors, which measure the pressure of a fluid or gas in a system. All right, so instrumentation sensors. These give feedback on the power unit for safety and maintenance and allow for troubleshooting of the system. While not required, they can help lengthen the system lifespan. And these gauges give analog feedback for operators. Switches give mechanical feedback, which can be used for simple controls. Transducers give digital feedback that can allow for more advanced computer control. The most common measurements are for pressure, temperature, flow, and reservoir oil level. Now, in cylinder applications, common sensors include stuff like proportional valves, pressure transducers, and built-in linear position sensors inside the proportional valve. And in cylinder application, feedback is important for accurate control and monitoring of hydraulic or pneumatic systems. Here are some more details on the types of important feedback. You have your position sensor, and the linear position sensor can be used to measure the point of a cylinder's position, piston, or move other moving parts. And this information can be used to control the cylinder's movement and position, or provide feedback on the performance. Pressure transducer, and this can be used to measure the pressure inside the cylinder, like I stated before, which can actually be used to control the force applied by the cylinder, or just provide feedback on system's performance. So another thing that's important to touch on real quick is a closed loop system. So a closed loop system uses feedback from sensors to control the system's operation, while an open loop system does not use feedback. Closed loop systems can provide more accurate control and monitoring, but they may be more complex and expensive to implement. Therefore, for cylinder applications, you'll need a proportional valve. A proportional valve specifically will close the loop. It can be used to control the flow of fluid into and out of a cylinder, allowing for precise control of the cylinder's movement, position, and pressure. By using these types of feedback, it is possible to control hydraulic or pneumatic systems more accurately and efficiently, leading to improved system performance and longevity. So, there are three types of temperature and or level sensors that are important for us that we distribute through Zemarc specifically. We have the Barksdale BTS, the Barksdale BLS, and the Tempesonics LLE and LLH. So the Barksdale pressure transducer, which as we stated before, this takes an analog reading of a pressure and converts it into a digital reading for your computer like a PLC. And on to linear position sensors. And here's some numerous options that we offer through Tempesonics, but just a little bit further on the discussion of Linear position sensors. And what these do is they take an accurate reading of the cylinder as it actuates. Some considerations that must be made for these types of sensors are resolution accuracy, desired output, operating conditions, and vibration and shock. So, with these sensors, the feedbacks provided, there's a multitude of feedbacks. But with like stuff like the Tempesonics, you can get digital feedback or analog feedback, and it really depends on the specific sensor and application. Analog feedback provides continuous real-time data on a physical parameter, such as position or pressure, in the form of an electrical signal that varies in voltage or current. Digital feedback, on the other hand, provides discrete data in the form of digital signals that represent specific values or states, such as the position of a piston in a cylinder. Digital feedback in sensors like the Tempsonics R Series 5 is designed to be compatible with various digital feedback industrial Ethernet standards, including Ethernet IP, SSI, EtherCAT, PowerLink, and Profinet. This allows for seamless integration into various industrial automation applications, and the sensors are also designed to be interchangeable with prior R series versions, providing greater flexibility and compatibility for someone that was looking to upgrade or update their system. So, linear position sensors utilize the properties offered by specially designed magnetostrictive waveguide. A short current pulse generated by the sensor element is sent through the waveguide, and this creates a momentary radial magnetic field. A magnet connected to the object in motion generates a magnetic field at its location on the waveguide, and the momentary interaction of the magnetic fields releases a torsional strain pulse that propagates the length of the waveguide. And this ultrasonic pulse is processed by the sensor electronics and converted into an electrical signal. Now, so the speed of the ultrasonic wave is precisely known. So the time to receive the wave pulse is converted into a highly accurate linear position measurement. So a linear position sensor, like the Tempesonics G and R Series 5, they have things like very high accuracy and repeatability, conveniently no recalibration or ongoing maintenance required, and very reliable, robust performance in harsh conditions. So specifically with R Series 5, we'll go over some exact details, which it offers a digital resolution as low as 1 micron, 16 bits per resolution for analog feedback. Linearity is lower than plus or minus 0.01% factor safety, less than plus or minus 50 microns of accuracy, and once again, backward compatibility with systems using previous generations of sensors, which is very convenient for upgrading and updating a system. So, modernizing of sensors is an important step towards what we call Industry 4.0. And this is characterized by increased automation, connectivity, and data exchange. Upgrading to modern protocols like SSI and EtherCAT can provide high accuracy, while wireless solutions like Bluetooth and IOTT can improve communication and efficiency. These are particularly useful for factories and automated test stands with large-scale diagnostic needs. The R Series 5 provides those advanced diagnostics, and including operational statistics. TempoLink and TempoGate comes with it, or integrated, for simplifying the reading of these diagnostics too. So the Parker SensoNode products are a series of wireless sensors developed for real-time advanced condition monitoring and diagnostics using your mobile device or computer. SensoNode Blue and Gold sensors are a part of IoT-enabled solutions that create opportunities for reducing downtime, avoiding dangerous situations, maintaining production levels through the elimination of bottlenecks, and improving quality. They provide measurements on pressure, humidity, flow, temperature, vibration, current, and flexible displacement, and are, once again, compatible with your existing sensors with 4 to 20 milliamp outputs. Also, quick note, Parker's line of proportional valves will be coming out in the future with Industry 4.0 compliancy features like IO Link interface and NFC connection. Overall, modernizing sensors can lead to improved efficiency, productivity, and predictive maintenance in various industries. So Here's a good list for our sensor solutions with some specific products we discussed today, like the Tempesonics R Gen 5, or the Tempesonics LLE and LLH, or stuff like the Barksdale, BLS, and BTS, or even stuff like diagnostic kits for the Parker Service Master, Serviceman Junior, Service Master, and Staff Diagnostic Kit. So here's a quick review of the necessary things to consider when speccing in a sensor into your system or power unit. Resolution and accuracy level, feedback type, which we discussed in length, updating and upgrading desires, much like you can update your feedback solutions to IOTT standards to modernize it. And of course, your application type for the unit. So also, here are some simple resources provided conveniently by Zemarc to offer more insight to the products we've discussed today and the details surrounding them. Thank you so much for taking the time to view this training. Zemarc and myself included are very happy to provide these trainings to you. And as always, feel free to reach out directly to us anytime by the phone and email provided on this presentation, training, and the website. We look forward to helping you with your future power unit applications. Thank you so much.